will be given the right to to load the presentations. And the question answer box, you will be also able to see all the question answers asked by the audience. Now some rules for the audience so far who has joined. You have chat and Q&A box. I'll request you to use chat for introducing yourself and question answer box for asking questions under your name. You can ask the questions during the presentation. Obviously, panelists will not be able to take the questions. So during the end of the presentation, they'll be able to take questions, or we will see if we can all the presentations are done. In the end, we take the question answers. So we'll see it as we progress. You have been put on mute, so you will only be able to ask questions if required. You can raise hand if you want to join in the process of if you want to speak and come on video to speak. You will have to raise the hand or write in the chat box about it. So this is how we'll function for next 2 hours. So it's already 10:33, and with the permission of our president, I think we should start. Meanwhile, other people will join.
Let's wait for 2 minutes. We can start at 10:35.
Okay, sir. We'll start at 10:35. So can we start now?
Yeah, we can start now.
Okay. Good morning to all the panelists and all the participants for a very important webinar which we have organized today, which is for stainless steel, an ideal solution for sustainable and growth and for architecture, building and construction. To start with the seminar, I would first like to invite our president, Mr. K.K. Pahuja, to give a welcome address. Sir, please.
Thank you, Rohit. Our distinguished speakers for today, Mr. N.P. Rao and Mr. Vijay Varghia, and distinguished delegates, we welcome you all. Special welcome to Mr. George Technical Institute, who are always with us and partner in our progress. On behalf of ISDA, I welcome you to this webinar on use of stainless steel for architecture, building and construction. Stainless steel, as we know, is a versatile material with multiple applications across different segments. Its sustainability, low maintenance, aesthetics combined with strength makes it a unique choice for architectural applications. We have some of the finest architectural landmarks across the world where stainless steel has enabled the designers' creativity to be translated into masterpieces of beauty, some of which we'll be seeing maybe in this session. See, in India, the architects and urban planners are discovering the versatility of stainless steel. The growth in high-quality construction like airports, metros, IT parks, hotels, shopping malls, etc., has seen unprecedented growth in last 2 decades. Government focus on smart cities, water management, and sustainable infrastructure has led to demand for new construction materials and technology. Stainless steel as a building material of choice is a natural corollary to the changing design and construction philosophy. Greater emphasis on life cycle cost in public projects is also a positive factor for use of stainless steel. We have already seen success of stainless steel in many areas like bus shelters, street furniture, gates and handrails, etc. But we have a long way to go to catch up with the trends in the advanced economies. We have already noticed early signs of demand emerging in stainless steel rebars, structural applications, facades and roofings, etc. As the demand grows, we as an industry have to gear up to meet not only the material requirement of quantity and quality, but build up matching service levels and the entire ecosystem of fabrication and erection to provide a total solution to the customers. So today we'll deliberate on the sterling qualities of stainless steel for architectural applications and what can be the roadmap to take it forward. With that brief introduction, I welcome you again and hand it over back to Rohit to proceed further.
Thank you, everyone. Thank you, Mr. Pahuja, for giving the welcome address. Now I'll request Rahul to give me the control for sharing my presentation. So the first presentation will be done by me, and then afterwards by Mr. N.P. Rao and Mr. Vijay Bhargava. Rahul, okay. Just wait. Rahul, the rights are still not there. Rahul, am I audible? Yes, I have received this thing. Okay, thank you. Okay, so my presentation, can somebody confirm if it is visible?
Yes, it's visible.
Okay. Good morning, everyone. Before I start my presentation, I would like to thank you for giving us an opportunity to have this presentation and listen to this. Stainless steel is a very important engineering material. Today, when we are struggling with the corrosion and issues of degradation of material in use for building and construction, it is the right time that stainless steel properties are understood and its value is understood. Before I go into the specific of building and construction, I would like to just quickly in 3-4 slides take you through where stainless steel stands for in present market. If you look at for last few decades, stainless steel has been growing at a very healthy pace, and this pace has been maintained throughout these years because compared to carbon steel, aluminum, zinc, copper, lead, even plastics, stainless steel is growing very fast. There are many reasons for it. I'll come to those reasons later, why stainless steel is being preferred choice of the material for building and construction. But if we look at the production of the world, India is the second largest producer of stainless steel in the world, and obviously behind China. And considering in last 3-4 decades where Europe and Americas has used stainless steel in a large quantity, last 20-year development in China, most of the construction activities has involved stainless steel. We are yet to catch up very fast, but we are not very far behind. Talking about India, yes, we are the second largest producer with touching almost 4 million tons last year. This year, obviously, there will be some downslide into the production of stainless steel, but that is natural because of the pandemic reasons. Per capita consumption is an important parameter or indicator of the use of stainless steel in general. 10 years back, we were at 1.2 kg per capita consumption. We have been successful in increasing the per capita consumption. When I say per capita, there are many sectors where stainless steel are used. Architecture, building construction is one, but process industry, like say milk production, without stainless steel, you cannot even imagine production of the milk or any food item, because it is hygienic and non-contaminant material is used for no contamination and all. There are areas like automotive, railway and transport. All the coaches today you see with Indian Railways are made in stainless steel, mix of grades. And there are many such areas where stainless steel is used. But ABC has a large chunk of it, and it is increasing very fast, and today we are standing at a per capita consumption of 2.68 kg. But if you compare it with other countries where the uses have been going on for last 4 decades, 5 decades, we have still a lot of ground to catch up. And so these webinars are one of the reasons why we would like to spread the knowledge of stainless steel and why it is an important material for the building and construction. One of the most prime factor before I come to the properties of stainless steel is that it's a very, very green material. These days, we are already struggling with the environmental issues, and any effort to reduce the carbon footprint should be appreciated. And stainless steel, one of the material which is highly recyclable, and despite having very, very long use, even after the long use, it comes to the recycling, it's all recycled completely, and it helps in reducing the carbon footprint. Why we use stainless steel in India? I'll come specifically to India now. In India, we have a large coastline, one of the largest coastlines, and along the coastline there are many cities. Mumbai is one of them. Bangalore is also. Chennai is one of them. Kolkata, and there are inland cities like say Delhi, Hyderabad, and such cities. There is corrosion due to sea environment. There is corrosion due to heavy pollutant and pollution going on, and material degrades. So what are those materials which are in use? Yes, wood is one of the material which is used in building and construction, but wood cannot be used in all kinds of forms, and it is prone to this insect, fungus, and degradation. Steel is one of the prominent materials used in construction, but again, steel gets corroded very fast. Concrete, which is sometimes used in combination with steel with a reinforcement bar, and the issues of corrosion and degradation of concrete is there. Cracking and spalling happens. Stone cannot be used in all forms, but still it has a different application. Glass in combination with other material is used, but glass is not very ductile, and it breaks. Plastics are used in many ways, not just for the chairs only, which is shown in the picture, but also for plumbing and many other applications in building and construction. These days, plastics are used, but under UV light, it becomes brittle and it also degrades. When I say it also corrodes, when I say corrodes, it doesn't mean just the corrosion of the top layer, but any degradation of the material is corrosion. So this also corrodes. Copper and aluminium is widely used. Copper has this tendency to form a green patina over a time. Aluminium also has issues of corrosion, as well as it has issues of strength, and all finishes are not available. Stainless steel, one of the prominent material being used since its invention in 1913. And just after that, if you look at the small photograph, Chrysler building, the first cladding of stainless steel in this building was done long back, and it is still shining and bright. So stainless steel has its role and prominent role in building and construction. But for some of the audience who are new to stainless steel, I'll quickly in 2-3 slides will talk about what is stainless steel. Stainless steel generally it is understood that it's a alloy of chromium, nickel, molybdenum, and other materials. But to make it stainless steel, basic stainless steel, you have to just add chromium into iron. So what chromium does, if you keep on adding chromium 2%, you look at this graph on the left hand side, there is a corrosion rate, and at the x-axis it is chromium percentage. So if you keep increasing chromium in iron 2%, 4%, 6%, 8%, but if you reach at minimum 10.5%, suddenly it stops corroding like carbon steel. What happens, why this, after this addition of chromium, it becomes stainless steel? If you look at this picture, this video, chromium in steel combines with oxygen and forms a passive layer of chromium oxide. Now, this layer in material you have to cut, weld, and bend it. So when you cut it, this layer gets disturbed, or scratch it, it disturbed. But again, there is oxygen in air, and this chromium is available in the material itself. So this again forms a passive layer of chromium oxide. So this layer is self-repairing. Even if you keep disturbing it, scratching it, it will keep forming chromium oxide layer. So this is a very thin passive layer, and it keeps forming, and the reason why it doesn't, stainless steel doesn't corrode easily. When we say stainless steel, please understand we are saying stainless, we are not saying stain free. So there are many grades of stainless steel which I come to, and there are many there are issues of selecting right surface finish, which will take up all these matters today to understand why good grade, good surface finish, and other properties of stainless steel should be selected carefully for a particular application. So basically, stainless steel does not rust easily, and the reason now, coming back to the alloying elements, chromium is the reason for not getting it, so not stainless steel becoming stainless steel. Now, when you use a material, you should have a ability to bend it very easily, and uh, cut it very easily, and join it very easily. When I say join, it can be welding. When I mean joining, welding, I mean joining. For joining, I mean welding. So to improve the ductility, toughness, weldability, you add certain amount of nickel into it. Now, for certain reasons where corrosion resistance requirement is high, where salts are present, and you need better pitting corrosion resistance, molybdenum is added into stainless steel to improve its corrosion resistance. Nitrogen these days, with the advent of new technology in 90s of argon oxygen decarburization, the ability to put nitrogen into the melt was introduced, which is a austenitic stainless steel stabilizer. And in some way, it also improves pitting resistance a little bit, and definitely it increases strength. So nitrogen bearing stainless steels were also uh, uh, introduced. So these are some of the major alloying elements. Apart from that, there are other elements like titanium, niobium, and other elements which improve some of the welding properties or malleability properties are also added. But for the architecture, building, and construction, will restrict to the grades and family of the grades, which is most widely used in building and construction. Now, you must have heard many names of stainless steel like 304, 202, 2205, 430, and all. So to understand it, I have divided into four basic categories. The first one is austenitic stainless steels, and these all stainless steels are made based on the composition of the alloying element, where some element is more, some element is less. Like say, some are only chromium based, some are chromium nickel based, some are chromium nickel molybdenum based, some are a balance of chromium, nickel, and moly based. So first, understand the austenitic stainless steel. Austenitic stainless steels are stainless steel which are non-magnetic in nature and mostly used in building and construction. These are very good in ductility, very good in weldability. They can offer different finishes and signs. There are categories of stainless steel into it: 300 series, 200 series. 300 series workhorse is 304 and 316L. 304 is chromium nickel based stainless steel. 316L is chromium nickel moly based austenitic stainless steel. So these two, you often hear these names, 304 and 316L. In duplex stainless steel, it's a mixture of ferritic and austenitic, where you need more corrosion resistance as well as high strength. So in tubular construction, or where design, where you want lighter design and higher strength, I'll come to all these. So duplex stainless steels are like 2304, 2205 are used, common names. Ferritic stainless steel is also used in AB architecture, building construction. Limited use is there, but there are grades like these are not non-nickel based grades. Straight chrome ferrite grades are like 430 and sometimes 441 and 44 grades you will be encountering. Coming to to the attributes of stainless steel, why you want to use stainless steel? You are all aware that it has excellent corrosion resistance. But apart from corrosion resistance in building and construction, you need very good strength material, where strength to weight ratio should be very good. It should be easy to clean. Cleaning should be self-cleaning, as well as cleaning should be easy. Considering a handrail where you touch it all the time, it should be hygienic also. It should have a good energy absorbing characteristic, good high temperature resistance, recyclable, and it should be available in wide range of finish. I'll come to all these properties and try to link it with the application. But apart from these properties, there are certain other requirements also, like what about the requirement of accidental blast, or in terms of architecture, building construction, I'm saying tsunami, drought, landslide, high wind speed, tornado, hurricanes, even earthquake. These days we are encountering earthquakes every day in our Delhi capital region. Fire, very important factor, maybe terrorism or some vandalism. So these are also unwanted factors which also plays into picture while doing material selection. Now coming to some of these properties, excellent corrosion resistance. Just one example I have given on the top. There is this stainless steel water pipeline. It was installed, now it must be 20 years back. This Metro dam, where you don't have to transport raw water from a long distance over the hill to the summer storage point. So earlier it used to be steel pipeline, and then it was replaced with stainless steel. These pipes are working very fine for long years, and corrosion, there is no corrosion. Structural integrity is compromised, like say in the picture in the right hand bottom side. If there is corrosion, then all the structural conformity is compromised. As I said, there is a wide range of stainless steel you can choose from. So left hand side on the bottom, you see there is 409 grade, which is a very basic grade, 11.5% chrome, which is ferritic, martensite grade, ferritic and martensite grade. 2205, which is a very highly corrosion resistance with a great PREN number, pitting resistance number, and in between there are many grades. So grade selection, where in between you have 316L, 304, even 430 and such grades. There are high strength grades such as duplex 2101, 2205, 2304. So there is a selection of grade, there is a range of grade available to select for a particular application. So it is important to understand the properties and application of the grades. Say for example, the strength, if we understand the strength to weight ratio. So you all know that if you look at this graph, this is stress versus strain curve for carbon steel, and compared to some of the stainless steel like austenitic, duplex, ferritic, and other grades of stainless steel. Some of the stainless steel, like say austenitic stainless steel, they have this property of strain hardening. So by strain hardening, I mean if you bend it, you do some kind of reduction on it, then its strength start increasing because of the strain hardening effect, and with a little less loss in ductility. So generally these grades, duplex, austenitic stainless steel, and some of the martensite stainless steels are very high in strength. And austenitic stainless steel in particular, 304, 316, when cold work, they also exhibit very good ductility as well as strength. Now look at this picture. There is a simply supported beam where the elephant is standing. So if you have to reduce the thickness of the platform, you have to use a high strength material. So if you choose stainless steel, high strength stainless steel, then you are able to reduce the thickness of the platform. So you have more space beneath the platform, as well as same load can be taken. So this is to similarly for the cantilever beam. If you want to keep the same thickness, then if you have a high strength stainless steel compared to other material, you can have a longer platform. So the idea is that if you are going to use stainless steel as a high strength material, you will always be able to save material in design, as well as create more opportunities for the designer to work with. Some of the examples, like say this Parliament Building Library dome, which was very long back, it was made in stainless steel structures. It takes less space, it looks good, it has good combination with wood, glass, or any other material. Similarly, not very late, this Afghanistan Parliament was done by Indian government only. CPWD was involved, and they used duplex stainless steel tubular sections for their central dome, not only for the lighter structure, but also if there is any vandalism or terrorism, it can withstand some of the loads. So higher strength lighter structures are possible using stainless steel, good cantilever, smart handrails, because you have high strength material. You don't need much of the load supporting elements, small load support, and it withstands the load. One petrol pump, this is again very old picture, for lighter aesthetic and maintenance free structure. If you go with stainless steel, it gives you value in it. Though I'll come to the initial cost and life cycle cost of it later, because many of you must have this question in your mind whether it is very costly or not. Now, another factor is impact strength. You know that stainless earlier all the coaches were used to be cotton steel ICF design, which was in a way not very good, having good impact strength. When you are using stainless steel, you had this ability to have a good impact strength. Now, I'm showing this picture because I want to take you to the next picture where this impact resistance property of stainless steel can be used. So if you cold work and make some of the stainless steel in trapezoidal section, then it increases the impact strength. One of the many very common example is the bollards, used not only for aesthetic purpose, but for the purpose that it can withstand some of the hit which it can get from vehicle or terrorism. This very beautiful example is from 7th World Trade Center. So after that, after 9/11, some of the buildings has to be protected for terrorism. So they choose stainless steel because it is very high strength, as well as it takes, it doesn't, the look of the building is still maintained. Instead of using very thicker section of other material, stainless steel is used to get it done. When you recall in the beginning itself, I said not just the properties of stainless steel, but some of the unwanted things happening, like hurricane. This is airport in Vizag. This is in Odisha. Recent cyclones over last 2 years. These two airports has to be shut down for almost 3 to 4 days, and massive amount of loss, not only in terms of material, but in terms of operation also was also happened. So they use polycarbonate seats, and not and they are not interested in choosing stainless steel in the beginning. So we have been talking to airport authority that all over world, most of the airports where they are prone to hurricanes and tornadoes, they are built in stainless steel, because stainless steel does not corrode not only the seats, wind pressure on seats, but at the joints where it is connected with the steel bolts, corrosion happens and it gets loosened up, and results in some kind of tearing and breaking. So stainless steel roofs are popular. So we should also be realizing the importance of it and start using it. One of the examples, very early examples of stainless steel roofing was in Mumbai near Kopar Kherne station, where these 304 polycarbonate seats, 304 painted seats were used for construction of these roofs. They look beautiful as well as from outside as well as from inside. And so far there has been no issue of maintenance, leaking, corrosion happening at these roofs, and we have been recommending railway to use much of stainless steel roofings. Impact was a property. Fire is also a very important property. Say for this stiffness retention factor versus temperature graph. If you compare austenitic duplex stainless steel and carbon steel, so bottom line is the carbon steel, and both two are stainless steel. So if you look at stainless steel, even at 600 degrees centigrade, it has retained almost half of its strength. Whereas in carbon steel, above 400 degrees centigrade, the strength falls very quickly. What this property suggests is that in case of fire, if structural stainless steel is used, you will have more time to evacuate the building, as well as like say for the World Trade Tower collapse. If it would have been stainless steel, you would have much more time before the stainless steel before the structure loses its strength and collapse. So these properties are very important when considering stainless steel, not only here but also for the paneling of the building. When you do some building facade for I'll come to that point also, then these fire properties also help. Similarly, there are wire meshes available for mesh sealing on the top. So everywhere sealing is done. Earlier it used to be in asbestos, which is now banned. Now there are material which are supposed to be fire retardant, but unfortunately not all materials are fire retardant. So if stainless steel used for mesh application, then this is one of the idea I would like to throw in front of you to use for building and construction. This question must have come to your mind also, that if you use stainless steel roof, then it will heat more and accumulate more heat beneath the roof. No, it is not the case. There are two things I would like to tell you. There is something called solar reflective index, and stainless steel is more efficient in reflecting solar energy than typical roofing cladding material if the surface finish is selected in a certain way. So stainless steel with a certain surface finish will reflect more compared to white paint and asphalt. So this is also a experimented, documented fact. And with a proper selection of stainless steel, you will have a cooler roof beneath the stainless steel. Now it is recyclable, reusable. This example I give everywhere is from the top is from 1952 Pittsburgh. This was done in cladded in stainless steel. In 2002, some people thought of renovating it, and they removed the panels, reused some of the panels, repolished it and added some material, and they used the same thing for the same building. And so the purpose of saying is that it is just not recyclable. When I say recyclable, means capturing and melting it and making stainless steel again. It can also be reused in certain way. It's hygienic, easy to clean. It is as stainless steel, if properly finished and used, it is as good as glass in China, and it is certainly better than plastics. So if you have to use stainless steel in a place where hygiene is required, it is the material to choose. Now, is the stainless steel costly? See, cost depends on the cost of corrosion, which you are incurring every day, and cost of maintenance you are again incurring every day. So, in spite of just not the initial cost of the material is important. What is more important is that whether you are going to lose the material in a certain period of time, and then to maintain that material you incur a lot of cost. So from there, the law cost concept of life cycle costing comes. But let us understand the cost of corrosion quickly. In the United States economy, over 300 billion is annually lost because of corrosion, which is about one third of this cost is avoidable if we use better technology and better material in that sense. And this begins with the selection of anti-corrosion material like say stainless steel, and start verifying the life cycle costing in the project stage itself. Because in the beginning itself, if you estimate the life cycle costing, then you will be able to choose the better material. And the direct cost of corrosion in India is also 2.4% of the GDP, which is huge. So the picture which you see in the left hand side is of the Andheri station in Mumbai, which has fallen due to corrosion over a long period of time. Now, just one example like to give you, that Golden Gate Bridge made in 1937. I mean, yes, you will say that it has lasted for more than 60 years, 70 years, but please understand that you have a whole department to maintain this bridge, which is 13 iron workers, 3 pushover workers, 28 painters, 5 paint laborers, and a chief bridge painter is there just to maintain it. They start from one end, reach to the other end, and the corrosion starts happening at the other end. So they keep on painting, and incurring cost into this bridge even today. So if a similar bridge, like say, I missed to put the photograph, there is a stone cutter bridge which has been made in stainless steel. No maintenance is required. Life is more than 100 years. Duplex stainless steel is used. So life cycle costing is important. Now you will ask me that how should we attempt to calculate the life cycle costing in your projects? So it is not very difficult to say. There are tools available to do the life cycle costing, but I'll suggest you to go to the Indian standard. There are two Indian standards which is mentioned here to give, which gives a guideline for life cycle costing analysis. So if you are doing a government project, this standard helps you to calculate life cycle costing. You can contact ISDA. The contact will be given in the end. ISDA can be also contacted for life cycle calculators available with us, and we will help you to calculate the life cycle costing. There are several other international standards available for life cycle costing analysis: ASTM, New Zealand, ISO, NS. So you can use these standards also. So it is easy to calculate. The only thing is you have to keep data ready for estimation ready for if what would be the maintenance cost or other cost associated with the project. So what I'm trying to say is that you must do the life cycle costing analysis of a project, and you will find that stainless steel in terms becomes cheaper over a period of just 20 to 25 years only for many projects. Maybe I'll give one example later. Another characteristics of stainless steel I would like to touch upon today, because some of the audience I truly believe will be interested in knowing this, is the energy saving characteristic of stainless steel for the buildings. This slide I have taken from Nickel Institute presentation, which says that the US statistics of building is 36% of the energy use, overall energy use, goes into buildings. 30% of the greenhouse gas emission responsible for, and 12% of the potable water consumption. So buildings are very important when it comes to energy saving. How stainless steel helps in doing it? See, these days the concept of screens over a building is getting prominence because you use some of the glass buildings, buildings mostly made of glass, and results in higher uses of air conditioners in warmer countries or warming for in colder countries. So considering India, which is mostly a warm country, in summers there is a huge issue of heat, and as well as in winters right now. So you use these sunscreens to reduce the energy need. There is a software called Kaufman 5.0. You can Google it. It is available free of cost, and you can go and model some of these sunscreens to see in your building design if certain kind of sunscreens will save energy or not, where you can choose stainless steel. Now these stainless steel panels can be of many type. It can be fixed type on a fixed frame. It can be movable, where you, according to the direction of the sun, you can move these. And if you look at these three figures, so unshaded wall 34 degrees, shaded wall 27 degrees. So there is an immediate reduction in the front wall itself, and inside there is more reduction, 20 to 25% of the energy saving because of the sunscreens. So to give an example, in India, in Kolkata, we have this building called Galleria 67, where these movable panels have been fixed, and these are colored panels. In our later presentations, you will be taken through some of the finishes of the stainless steels and why it is important to choose the right grade, right finish, so that there is no issue. So these panels helps in doing it. We have one mesh facade in Yamuna Sports Stadium when the Commonwealth Games happened. Uh, some of the sunscreens used are for planting also. So if you are doing some planting, you need to have ropes and wires in front of it to plant for plants to grow. And in steel, you can understand it will easily corrode and these plants will fall. So you use stainless steel ropes to do this, or mesh to do it. Also for existing building, in the background there is existing building which was supposed to be made non-functional, but because of the, I mean, they wanted to improve the design of the building. So instead of demolishing and making it, they just put a facade in front of the building. Now this is a laser cut panel in front of the building, and the beauty of the building, it becomes a tourist. The same building becomes a tourist attraction, and utility of the building remains. Now, if you ask me whether there will be an issue of light coming, I mean there will be reduction in the light in the background. So this is the same building, and there is no issue of lighting inside because the panels it's have to be designed in certain way. Some of the other areas I'll quickly touch upon because I'm already reaching my time, and in fact I'll exceed my time if I do not conclude quickly. Plumbing is one of the fast rising application of stainless steel. Plastics no doubt have because of the very competent cost, it has gone into buildings, but please understand that in a building you invest in your kitchens, bathrooms, a lot of money, and put costly tiles over it, costly material in your toilets, and if the seepage occur because the leaking from the joints, the whole area gets disturbed, and you have to tear it up and then do the repair work, and it incurs a lot of cost, and your own cost which you have invested goes waste because the little investment you could not do into plumbing. So I'll recommend for to use stainless steel. These days press fit technology is available, which is very easy to handle. There is no thread has to be done. You just take a joint and all kinds of joints and press it, and it works even for a high pressure building, like say for the CPWD itself. Many residential quarters, IT Delhi, these days Parliament building, the new Archaeological Survey of India. So CPW has used a lot of stainless steel press fit pipes in their projects, and I'll recommend residential buildings, private residential buildings also to use stainless steel, not only for the hygienic purpose because plastics are not safe. Some of the PVC pipes have, in Hindi it is written, has lead into it, which is very dangerous for consumption. So these are the rising application. More information is available with ISDA. If you need any information specific to stainless steel plumbing, please write to us, please call us, we'll help you in all aspects. Water tanks are becoming very popular. You use plastic water tanks, very dangerous because it has some of the chemicals will leach into the water when the sun falls into it. It is prone to cancer. It has been reported that some of these are prone to cancer, and stainless steel water tanks are available these days in large numbers, not only the double wall, single wall, as well as some modified tanks for your loft tanks, for your for your balconies, for your particular use. They can be modified to any shape, size, and it is available. Also further information can be provided on it. Some of the infrastructure, like say if you are involved in making a park, stainless steel is plastics decay over a time, and generally it breaks. Steel nobody uses because it is prone to corrosion and septic. So stainless steel is predominantly being used in parks and areas of where which is safe for environment and kids. Please think about it. A lot of sculptures are being made in stainless steel for the beautification of the city, and stainless steel is most preferred material for it. This charkha is made in stainless steel, which is at Connaught Place, Delhi. Sprout at near Ames, which you all have seen. This tree made in stainless steel is near India Gate. And in many parts of the country, such sculptures are coming up. So if you are an architect, you are involved in some such projects, you have stainless steel available. Now it is available in many colors also. So you have great choice with stainless steel, which can withstand for a long, all kinds of environments. Uh, Now coming to the signages, bus stops, and hoardings, stainless steel is a preferred choice of material these days because Delhi is a proven case for bus stand as well as signages, where first the use started, and now all over country, even to the remotest of the places in Assam, in through 2 to 3 tier cities like Patna, also they have 80 bus stands in stainless steel. So stainless steel has proven to be a great use for public utility items. Handrails, obviously, many would think that why to put a stainless steel railings on a public place near roads. See, this is in Mumbai, this is in Chennai, near the sea, Marina Beach, 2, 3, 4 kilometers of stainless steel rails. Delhi, so see, these are prone to kind of vandalism as well as corrosion, as well as people have habit of making it dirty, posting posters, spitting on it. So stainless steel has some properties of self cleaning as well as easy to clean also. So these helps in cleaning also, as well as improves the aesthetic of the building also. For public furnitures, this is the same area in Mumbai. Long time back, it was remodeled and started looking beautiful. People started spending time. So street furniture is one of the great examples for the use of stainless steel. I'm not saying that it cannot be used in combination with other material. It can be used in combination with wood also, stone also. But stainless steel as a material gives a better choice for these places, not for the aesthetic purpose, but for the corrosion as well as long life and beautification purpose. Public sanitation, these partitions are getting popular these days for because it is very strong vandalism proof as well as looks beautiful in areas where you have to segregate. Urinals are also available in stainless steel wash basins. There are many other examples, but due to the paucity of time, I would restrict my presentation up to this only. I hope you must have liked this presentation, and we'll take the question answers because there will be many questions, many other next two speakers will have many other aspects of stainless steel to share with. So I request you to keep posting your questions into question answer box, and we'll respond to it one by one. So with this, I end my presentation now. Okay, so now I would like to invite Mr. N.P. Rao for his presentation. Mr. Rao. Okay, so
thank you, Rohit.
But let me introduce Mr. Rao to you. Some of you who doesn't know him. He is the director at Pegasus Consulting. Pegasus Consulting offers solutions in various fields, including technical assist and other assistant in stainless steel. He has 35 years of multinational steel industry experience in India and abroad, and specializing in strategic management, technical support, stainless steel marketing, and business development. He and his team has been instrumental in many of the development works in stainless steel related to stainless steel, and considering the stainless steel for architecture, building, and construction, no other person better than him to address you. So with these words, I would invite him to load his presentation and address the attendees. Thank you, sir.
Thank you, Rohit, for your glowing introduction. I don't know whether I deserve it. So good morning, everybody. It's my privilege to speak on this very important aspect of building industry. And let me just... Thank you, ISDA team, for organizing this webinar as well. Can everyone see the slides, please?
Yes, sir, we can see. You can make it full screen.
Yeah, I've done it.
Yeah, visible.
Visible, thank you. Since our eminent speakers, Mr. Pahuja and Rohit, have already stressed the need for usage of stainless steel in the ABC sector, architecture, building, and construction, and actually Rohit has gone and detailed the material aspects as well, and shown some important applications, and also proved why stainless steel is the ideal material in building construction in terms of various aspects. I will be touching upon some of the finer aspects of surface finish of stainless steel, mostly relating to building industry. The stainless steel surface finish is a very important design aspect in the selection of material for the building industry. It is important to provide good aesthetics and appearance, and especially in the architectural applications, the visibility and aesthetics makes a lot of difference. Stainless steel has a wide variety of special surface finishes, which no other material can match. And surface finish is a very, very important aspect of the specification, and it has to be suitable for the end use. So the selection of surface finish of stainless steel is very important with relating to the end application of stainless steel. And some of the non-decorative applications also, stainless steel surface finish is important in terms of implications for the friction, maintenance, or corrosion resistance. So the stainless steel surface finish must be identified by a standard industry designation or by a specific trade name. And the choice of stainless steel surface finish should not be left to the supplier, or the specification should not be loosely worded, but it should be very specific, just as it is for a grade. For example, a 304 grade with a 180 grade finish. Which these things make a lot of difference in terms of selection of right surface finish for the stainless steel application. Here we have two pictures. The picture on the left is showing you stainless steel covered dome, and this is located near the sea. The picture on the right is also using colored stainless steel, but as you can see, the stainless steel is worn out because of various issues, because the wrong type of finish was chosen in the wrong application, and probably the PVD color coating was not done properly, and it was not investigated to suit the design. Whereas the building on the left has stood the test of time and it is still going strong. Some of these aspects Rohit has covered in detail for stainless steel, but I'm just trying to compare some of the properties with the other material, which is stainless steel, galvanized steel, plastic, and aluminum. And the green colors on the left-hand side of the properties indicate that these are certain things which are important for the building construction industry: corrosion resistance, environment friendliness, life cycle costing, which Rohit was talking about, hygiene, very important, ease of restoration is very important in the building industry, safety aspect, fire resistance, again Rohit has talked about it, and the leadership in energy and environmental design, which I think it was covered in the previous presentation very nicely, showing various aspects, including energy conservation, lighting, preservation, etc. And of course, stainless steel, very importantly, scores very high on range of surface finishes. So we just wanted to compare these with these materials, and of course, wood and concrete and other composite materials are not compared here. Common stainless steel surface finishes. So we have various types of surface finishes which are produced in various process stages. So you have the hot rolled stainless steel mill finishes. The first one being the hot rolled stainless steel black, which is as rolled. Then you have the hot rolled annealed and pickled stainless steel, which is called the number one finish, which is after rolling, it is hot rolled and pickled. Then you have the cold rolled mill finishes. This is the cold rolled hard, which has got a high hardness, 2D, 2B, BA, and dull finish. You have the mechanically polished finishes, number 3, number 4, hairline, number 8, and so on. And there are some more of these. Then you have the special rolled finishes, embossed, single side and double sided. There are other special finishes as well: acid etched, PVD coated, deep blasted. Then you have the anti-fingerprint coating. Then you have the latest in stainless steel finishes, so the 3D printed finishes, and you have the electro polish finish. Coming to the processes, how these finishes are made. So it can be divided into a few major categories: mill finishes, mechanically polished finishes, special finishes, 3D printed finishes. And surface finishes are produced either from basic mill production, as we saw in the previous slide, that can be rolled or unpolished, or from subsequent operations to enhance the brightness or impart another finish. Now, mill processes could include hot rolling, cold rolling, annealing, including bright annealing, pickling, and skin passing. And mechanical polishing could include grinding, polishing, including electro polishing and buffing, etc. Then you have the special finish processes, including embossing, acid etching, PVD coating, brief blasting, 3D printing, and anti-fingerprinting. So these are just the various processes. In the previous slide, we saw the types of finishes. Now, this slide we have shown to compare the standards which are available across common standards in the world. So we have compared the ASTM, which is the American Standard Society of Testing Metals, the Bureau of Indian Standards, and the European standards. So these standards are for the finishes alone, and we have compared so that a lot of these materials is available from various standards in the country, and often the mills supply their standards in their own country standard, the test certificates. So it is important to know what is comparable, because in India we have to use BIS for all specifications of stainless steel. So for example, the hot roll number 1 finish in BIS and ASTM is called number 1, whereas in the EN finish it is called 1D. Whereas the cold roll finishes 2D and 2B are actually identical in all the three. Coming to the BA finish, you'll see a difference here that under the EN standard they call it as 2R. So we have just differentiated this and given the description here so that people understand what is the difference. And of course, this is very important. All steel flat products sold in India must conform to the latest revisions of IS 6911. This data, of course, is compiled from various standards. Most common finishes which are seen all around us are probably the number 4, 2B, and the BA finish. And even in the building construction industry, as you enter a tall multi-story building, especially an office building, you'll probably see the number 4 finish outside of an elevator door, on the switch panels, inside the elevator, on the columns, on the walls, and many other places of common area like water coolers, etc. 2B finish again is the most commonly used finish worldwide, and BA finish is highly reflective. So we have just put this picture to give you an idea of the different textures of the finishes and the kind of reflectivity they provide. Now this something is unmatched by any other material. And the stainless steel number 8 super mirror finish has high gloss, and is practically having a gloss of 99% the true mirror. And this can actually give you a feeling of a lot of space and reflectivity and elegance, and it gives you a high aesthetic appearance. And once again, it is used for various applications in column cladding, building cladding, and a lot of other applications, as you can see. And the reflection is very high, and it is just majestic, probably unmatched. The number 4 finish, this is produced by using different abrasive beds in an oscillatory method, and the finish is having grains, as you can see. It is not very reflective, it is multi-purpose, and it gives a very fine appearance when it is used on very different processes. Within the same process line, the finish can vary if the belt wears out, and the finish can vary from different suppliers, raw material, or even from different lot of raw material. So it is very important if you're going for an architectural application, be it column cladding, be it wall cladding, or any other paneling work, or a facade, it is important to select the entire lot of material from the same lot of raw material or from the same source, so that there is no difference in the finish. Otherwise, it can make a difference in terms of the tinge, etc. Once again, the hairline finish, very similar to number 4 finish, but these grains are more oriented. They are continuous lines, and it is less reflective, less prone to fingerprint impressions, and applications are very similar. It's a little more rough handling in nature. So, you know, a lot of these hairline finishes actually are now getting prominence in India, but primarily in Japan and Europe, they were very commonly used. Coming to the surface finish standards for some of the mechanically polished finishes. Once again, we have compared the three standards here. For example, if you compare the number 4 finish, the ASTM and the BIS both classify as number 4 finish, whereas under the EN finish, it is classified as 1J or 2J. Coming to number 8 finish once again, which is the mirror finish as we saw, ASTM and the BIS designated as number 8, whereas the EN designated as 1P or 2P. Now, there are some very important aspects of mechanically polished finishes. This is just a representative drawing of a designer's office where we'll be selecting material to design or specify for a particular application. So the correct specification is very important to ensure that the ideal material is chosen in terms of lower corrosion resistance, longevity, hygiene parameters, and aesthetics, which are all very important to the architecture, building, and construction segment. Clear specification is important to optimize the benefits of usage, and it also eliminates the communication issues between a fabricator and end user. So we have the specifications here. So this finish is 2J, grade is 304. This is just an example. Thickness 1.5 millimeter, and roughness, surface roughness is specified with the relevant gloss values. And this is what is the range which is to be. So you are covering all the aspects of specifying the material for the application. And once again, for a mechanically polished finish, avoid the mix-up from different lots of production or from different mills or different service centers. Again, for the reasons I explained a little before. There is also another aspect of choosing a mechanically polished finish, which is a parameter of reflection of light. So an elevator door actually could appear like this when you have a look, from the front. So when the light is put, you look at the difference in the finish. So when choosing this and while selecting the polishing line in the polishing line, choosing and inspecting, it is important to run the light and see how to do it, so that the finish is more uniformly seen when actually installed at site. Now, what are swatch samples? These samples are required so that when a producer produces the samples, or if you are the end user, you keep the samples as templates to match with the final supplies, because the mechanically polished finishes can vary. Once again, as we've been talking, it is important to keep this to compare and use the same material repeatedly if it is for the same application. We talked about some of the special finishes in the previous slides. Now, the very interesting part is the special finishes do not have any mention in the ASTM or BIS. Whereas in the EF standards, there are lots of finishes which are specified in the standard. For example, the 2F finish. This is not specified in ASTM or BIS. Whereas in EN, it is cold rolled, annealed, skin passed. It is a non-reflective matte finish, and it can be on the base finish of a 2B or 2R, which is 2B or BA finish in our parlance. So it's a base finish, and then you have the special finish on top of it. Similarly, you can see the other finishes. Each is described here, but there is no mention in this, which means they have yet to standardize these. Some of the special surface finishes shown here are embossed, single side, double side. These all can be produced on either side of the material, can be single side or both sides. Then you have the PVD coated color finishes, which can be produced on a mirror, it can be produced on number 4, it can be produced on any base finish. Then you have the acid etch finish. Once again, acid etching can be done with any kind of pattern, and this acid etching can be a color finish or it can be a stainless steel finish. You have the bead blasted finish here, which also looks very matty, and it's a very good finish. It gives a impression that it is not reflective, so it can be used in a lot of applications where you have a lot of human touch. Then you have the embossed finish, which is also very good in terms of vandal proofing and scratch resistance. Of course, we have only shown these many here, but there are hundreds of such finishes available all across the world. Dull finishes, once again, these dull finishes are very good in terms of exterior application because they have high corrosion resistance from a finish point of view, because you don't see any grains here, and that can be used for a lot of cladding applications. And it is this 24 grit finish again is a unidirectional satin finish. It has a low RA value. It is a dry process made in skin pass film and good resistance from finish point of view. Now this building here uses this finish, which is a satin non-reflective dull finish. And you can see the building, Khalsa Heritage Center, picture taken in daylight of these domes. And this is the nighttime picture. And you can see the stainless steel finish on top of this roof. So we talked about this building in the very first slide, a very majestic architecture. The discs are all gold color dishes, 316 stainless steel with PVD coating, and I think it's been more than a decade or so, or 15 years, and there's been no damage. And this dome in Pondicherry is very close to the sea. So once again, it is proving here that the right finish along with the right grade has helped achieve this corrosion resistance and give the majesty of the building. Talking about LEED, which is the Leadership in Energy and Environmental Design certification. In India, Ashok Leyland building in Chennai was the first office building and 4th in the world to back the certification many years ago. And the panels used here are the stainless steel panels, and they are non-directional, non-reflective satin dull finish. This is a very new development. In Rohit's slide, we saw one of the wire meshes being shown as a fence and also for plant applications. So this is a wire rope, stainless steel wire rope, and the new application is color coating or PVD coating of stainless steel wire rope. This technology is yet to come in India, but there's a lot of application being used, and I think one of the airports in India is going to use this. Again, very fine applications of the same wire rope mesh. This is a black color wire rope mesh, the stainless steel, and this is at the fencing at Aviary at Mumbai Zoo. So look at the majesty of this application here. This is an artist's impression of a stainless steel dome, again using the rope wire mesh, and I think the building looks absolutely magnificent. Another use of the same thing, it can be used for cladding walls. Now, Rohit talked about hygiene, and we are talking here about all the finger touch sweat. And in the last 9 months, everybody's talking about cleaning, sanitizing, and whatnot. Now, by using the anti-fingerprint coating, you can prevent stains because of sweat or because of dirt or fingerprint, and it's easy to clean. And I think this is very, very important to use, especially in public touch areas like elevators and reception desks and other places. Electro polishing. Electropolishing is an electrolytic process. As compared to the mechanical polishing, electropolishing also can give you a very smooth, shiny, mirror-like surface. The advantage is that the surface finish at the surface of the material, the passive layer is not much damaged in terms of electropolishing, whereas in mechanical polishing, it is likely that the surface is slightly, eroded. And the structure of the surface remains same almost in electropolishing. So we are given the depth of the passive layer here. And the passive layer video was shown very nicely in one of the slides shown by Rohit as to what happens for the stainless steel when the chromium oxide layer rebuilds itself. And there are some applications for building construction as well, which can be used for electropolishing. Of course, it's an expensive process. Rohit talked about fire. Now, most of the fires in the exterior buildings have been there because of wrong use of material. And if we use stainless steel 3D printed color stainless steel or plain stainless steel with fire resistance thermal insulation coating, it can improve in terms of fire resistivity, and it can avoid, or we should avoid, aluminum composite panel for exterior paneling in multi-storied buildings. So 3D printed technology is gaining ground in India, and I know there are a lot of 3D printed companies in India who are actually printing metal, and I attended some of the webinars. It's really interesting technology, and I think it should be made use of because you can get n number of choices. Coming to surface roughness and gloss. Now, surface roughness is a very important parameter in terms of using the surface finish of stainless steel, where you can actually use a surface roughness instrument, measure the microscopic peaks and valleys of the surface of the material. Once again, the gloss is actually a term which is used to check the reflectivity of the material surface, and you can use gloss meter to see how much reflectivity or shine or gloss is there on the surface of the material. This is a typical measurement of a roughness of a RA value, peaks and valleys, and these can be obtained by using measurements. Some examples of corrosion by using wrong stainless steel finish. On the left hand side, this particular building, you can see that they have not only used a ferritic grade on the sea shore, which is prone to corrosion, they have used a ferritic grade with a number 4 grain finish. If they had used 316L with mirror polish, this problem would not have happened. And so the whole thing got rusted, and despite a lot of cleaning, it's still there and the building looks very bad. On the right hand side, again, due to the wrong finish used, there were water stains, etc. And of course, after cleaning, you could get this. So this is a good example because it did not rust. And this is another example where there are weld marks in heat temps because of poor fabrication. Laser technology for rust removal. Now, this is a new technology which is easy. There are lots of other conventional cleaning methods using chemicals, etc., which result in hazardous vapors, etc., especially when humans are involved in cleaning buildings. So if you use laser, which is a non-hazardous and non-abrasive cleaning method, you've got a lot of laser applications, very handy. It has a better reach and it can be used easily to clean such areas and also do the rust removal. Summarizing, surface finish is a very, very important element in any specification of stainless steel, especially in the building construction industry. And once again, the choice of finish should never be left to the supplier, or the specification should not be loosely worded. It should be very, very specific. Please consult ISDA, Pegasus Consulting, and your stainless steel manufacturer before choosing a stainless steel finish, which is so important. Coming to our services, We provide in stainless steel and other aspects, quality standards, troubleshooting, working on stainless steel technology, sales and marketing, cost optimization by choosing the right stainless steel material, process analysis to reduce cost and improve overall quality, and we do consulting for project process grades, new applications, quality parameters, finishes, fabrication, and it is all to achieve the business success for any enterprise. Thank you all for listening patiently. Thank you all.
Thank you, Mr. Rao, for this very informative presentation. For the participants, we will share this presentation, all these presentations to your registered email IDs, as well as we will upload the video of the presentation, this video of webinar on YouTube link, which will be shared with you also. You can also visit our YouTube channel by typing ISDA in YouTube, and you will find it. Now coming to the next presentation, it's a very interesting presentation, so I hope you will like it, and it will be done by Mr. Nagendra Vijay Varghia. Mr. Vijay Varghia, let me introduce him first. Mr. Vijay Varghia has worked with the prestigious organization Steel Authority of India Limited, Salem, stainless steel plant, and holds experience in many profiles, which includes quality control, marketing, sales of stainless steel flats and products during his entire work in SAIL. Needless to say, he's an engineer, and he has superannuated with SAIL and has been working with ISDA as a consultant very closely for the development of stainless steel. So he has lots of experience with him. Let's hear from him about his presentation.
Good morning to all. I thank ISDA to give me this opportunity. I am privileged to have this opportunity to speak in this webinar. Let me share my presentation.
Yeah, I'll request you, sir, to keep within your time limit, sir. We are already exceeding time limit. And in the end, we'll take a question, have a session for question answer also from the all panelists so far. It is loading. Yes, it is visible now.
Visible now? Okay.
Yes, you can go ahead, sir.
So, subject of my presentation today is role of stainless steel in restoration and protection of heritage buildings. To start with, this UNESCO has this guideline, caring for your heritage building. It is a building owners manual and very informative on this subject. It gives guidelines for stainless steel plates, screws, rods, etc., how and where it can be used. Even CPWD has a handbook for conservation of heritage buildings, where because CPWD is taking care of Parliament and Rashtrapati Bhavan and so many other buildings in the country. Now, this Indian National Indian National Trust for Art and Culture Heritage, INTEC, is also having a schedule of rates for building conservation works, where they are showing stainless steel bars, studs, tubes, etc. The schedule of these items they are showing. Now let us come to why stainless steel. Although Mr. Rohit has already covered a very important aspect of stainless steel, but I would like to show again corrosion resistance. There are various corrosions occurs in stainless steel, but there are two. One is general corrosion and second is pitting corrosion, which is relevant to the subject of my topic, subject of my presentation. General corrosion occurs everywhere, even for steel, and pitting corrosion occurs where chloride ions are present. next property is earthquake resistance, because it has got very good ductility and very good toughness. Ductility and toughness both together is having, stainless steel is having. Then fire resistance, stainless steel retains its stiffness at much higher temperature compared to other material. And of course, Rohit has covered life cycle costing, where I mean, if you want to preserve heritage for a long time, you need definitely a good life of the material without maintenance. I will just like to cover only 2-3 grades which are important for this. There are 3 grades which are important: 304, 316, and 2205. 304 and 316 both are called authentic stainless steel, and 2205 is called duplex stainless steel. You can see chemical composition in these, but the most important thing is PREN, is pitting resistance equivalent number. In 304 grade, it is 18. This number is derived by empirical formula using chemical compositions, how much chemical they present. So 18 is for 304, 23 is for 316, and 30 is 22 for 2205. However, if you see the grades, the mechanical properties of 304 and 316 are same, only hardness is little higher, 16, whereas in 2205 elongation is low, but yield strength and tensile strength is higher. Hardness is much higher compared to this 32 RC, because it is in other scale. So now the areas and parts where stainless steel can be used for restoration of heritage buildings: the stone and masonry wall reinforcement, ground and rock anchors, reinforcing cliffs and walls, concrete reinforcement, larger structural sections, poles, wall, ties, studs, tubes, rods, clamps, so many other parts can be used. There are so many BIS standards available: IS 6527 for wire rods, 6528 for wires, 6603 for bars and flats, 6911 for plate, sheet, and strips, and 16651 is for stainless steel rebars. IS 13174 Part 1 and Part 2 is a guideline for life cycle costing. Now let us come to the examples where stainless steel has already been used. The Sri temple in Puri in Odisha state of India. It is only 2 kilometers away from sea, and it is 66 meters high. No mortar was used during original construction, and stones were joined with the help of wrought iron U-shaped clamps or dowels. And maximum damage has occurred due to rusting of these clamps. How they have conserved? They have, of course, I am not a civil engineer, so don't ask me the civil aspect of this, but on the stainless steel aspect, you can definitely ask. The missing corbels were replaced by polymer modified cement, and these were fixed by stainless steel. And secondary line of protection was provided by constructing stainless steel truss to provide strength to corbelled ceiling system. Corner walls of each floor was done by stainless steel flats. Southeast portion of the structure was in bed shape. Therefore, each of the damaged stone blocks were removed and new stone blocks were fixed with epoxy mortar and stainless steel. And of course, the amalgamation were reinforced with stainless steel rods. Another example in India is Mani Mandir complex at Morbi, Gujarat. This was damaged during earthquake. It is a complex of 100 meter by 100 meter plan. In 2001, during earthquake, it got damaged. Perpendicular walls were securely connected to each other by cross pinning with stainless steel rods. And seismic features provided by 6 mm stainless steel reinforcement rods at certain spacings. there is movement of support and the arcs are internal. A stainless steel tie with turnbuckle is used. In areas where there is no discernible movement of supports, the keystone is tied back into the wall above by means of stainless steel rods. The lintel is formed by means of providing stainless steel reinforcing bars in the courses between the stone above the arcs. Another example, they have used stainless steel dowels for these walls. International examples, there were two buildings which are 1919 and 1960s, and they wanted to make a single building for Ministry of Finance. So they joined this building externally by this overlaid of looking this mesh of 12 mm thick. Around 60% perforation is there, so that light can reach the building. However, building looks single. Very important aspect of how stainless steel has been used for restoring Statue of Liberty. It was installed in 1886, and after 100 years in 1986 was done. Of course, original designers Mr. Bartholdi and Eiffel, they anticipated the problem, so they try to cover electrostatically by impregnated asbestos pads and paint on the iron. But unfortunately, the envelope design and subsequent modification to it allowed rain containing coastal salt and acid from pollution to seep behind the copper. So stainless steel type 316 was chosen to replace the entire iron armature, supported by duplex stainless steel 322550, and secondary framework 316 stainless steel was used. Now it is an example that at the beginning itself, if we use proper material, then there should not be any problem. In this mosque in Morocco, it was built in 1993 with cost of €585. And structural deterioration in the concrete wall was observed 10 years after the mosque, just after 10 years. So restoration work started in April 2005. The structural slabs and pillars on the exterior part of the mosque exposed to the sea were demolished, and 2205 stainless steel, duplex stainless steel was used with 1,300 tons were used to rebuild this, the pillars. And now they expect that it will be 100 years life will be there. Venice is under practically a floating city. Centuries have passed. They have built this city, and the rising water, sinking ground, high tides, wind, salt, water, erosion caused by hundreds of motorboats has caused a lot of damage to the city. So now they are using moly grade, that is 316 grade, extensively to use it. Of course, stainless steel, sometimes you can see, and sometimes it is behind the sea. Some of the examples where they have used 316 grade, they have replaced the brackets and pins for the walls. You can see the design here. Handrails, gas pipes, water bus terminals, reinforcement of cast iron bridges, etc. They have used here. You can see the pipes changed. The above bridge, this bridge was constructed with duplex stainless steel grade 2205. However, it has been clad with wood so that it looks same as the old bridge. Finally, coming to the conclusion that heritage buildings and monuments are very important assets for the world. They help us to understand our past and learn from it. They get damaged due to various environmental and climate reasons. restoration, preservation for a long duration with minimum maintenance is very crucial. So with stainless steel, its intrinsic properties like corrosion resistance, higher strength, permeability, earthquake resistance, fire resistance, etc. Stainless steel is very versatile material in helping us in this endeavor. Thank you very much. With this, I close the presentation. If any doubts are there, we can always.
Thank you. Thank you, Mr. Vijayavargiya. Yeah, you can stop the presentation now so that we all are on screen. Stop sharing. Yeah. On the top, there will be option stop sharing.
Yeah.
Rahul, can you do it from your end?
Yeah, it's done.
Okay, thank you. So this brings to the end of the presentation part. We all three presenters have given their presentation. And once again, I would like to thank Mr. Vijayavargiya and Mr. Rao for excellent presentation. Restoration of building has been a very important subject, and any restoration needs to be done in a way that it involves no further restoration in long time. Stainless steel perfectly fits the environment. So let us take some of the questions which has been asked in chat box as well as in question answer box. So one of the very early questions are like, are SS tubes in IS plumbing standards or Indian standard has any standard for tubes and pipes for that now? I can update on this aspect. See, there is a standard in process of the making for the press fit stainless steel for potable water. There are other standards of stainless steel also in the draft for welded pipe and tube for decorative application, seamless pipes and tubes for general application as well as industrial application. So all are under draft, various stages of the draft, and we estimate that in a period of 3 to 6 months, it will be in picture. Now the next question goes to Mr. Rao. The question is that, sir, any national or international standard which tells about the reflectivity and glossiness of stainless steel material? The connecting question is from the same person, Mr. Jivnendu Tripathi, is that gloss and roughness on special finishes are an agreement between buyer and seller. So
no, actually, that is my answer. That is my answer.
Okay, you
I have typed the answer in the chat box.
Okay. Yes.
So, I saw that, and so basically that is what we have shown in one of the slides, that it has agreed between the buyer and the seller, depending on the type of finish and the type of application.
Just to clarify it further, sir, when somebody is writing in the specification about the finish, so should they mention a particular standard, or they just should just mention the finish?
They can finish. They can mention the finish, or in terms of the grit finishes, they can mention grit size. Because as we saw in number 4 finish, the grid size can vary from say 150 to say 320. So if somebody wants a particular grid size and his end applications is say 320 grid and they are using 120 grid, then there will be a difference in finish. So it is better if the grid size is known in terms of grid finishes, that is to be mentioned. Whereas in terms of say mirror finish, if they know the gloss value, it is better to mention the gloss value.
Okay.
So there are some general applications that people just buy what is available from the sales and service centers and use. In that case, it is okay. But certain specific applications where people are using to match an existing finish. For example, if an airport construction is going on and wall paneling is done in a particular finish, and if you have to match it, then it is better to know what is actually used and then specify to the seller or the manufacturer. I hope that clarifies.
Hello, am I audible?
Yeah, you're audible.
Okay, so next question is to Mr. Rao only. That was regarding what is PVD, which the question is that what is the significance of implementing PVD? So where it can be used, how much would be the life, whether it is scratch proof or not. So all these questions.
See, PVD is a physical vapor deposition process to produce the stainless steel in different finishes by using different elements to impart the different colors. So it again depends on the end application and where you are using.
Okay. The next question is to Mr. Vijay Varghia. Hello. Varghia. Okay. So the next question is to Mr. Vijay Varghia, and the question is that
Question is
that restoration. Okay. Okay. I think there was some lag in receiving the data. So if I continue, the next question is to Mr. Vijay Varghia, and it is about near the sea, what would be better grade, 316 or 2205?
If you ask better grade in terms of fitting resistance, 2205 is better. However, it depends on application. The 2205 is having less elongation. So if there is some more forming is required, 316 can be used. And of course, 316 will be slightly cheaper. And 2205 can be used where it is in direct touch with the seawater.
Okay, sir. I think there are no further questions which I can see, and we have been finishing well within time.
Actually, Rohit,
okay.
Sorry, there is one more question from Mr. Tripathi again, where he's saying that there are multiple seller and multiple machines being used, so it becomes difficult to certify. So, can I answer that question?
Yes, go ahead, sir.
Okay, which is why we have shown in our presentation, and this is what is the right practice, that for a particular set of application, you should use the material of the special finish from the same lot. Not only from the same lot, from the same supplier, and if possible from the same lot of production. Because this is encountered almost on a daily basis by the building construction industry, and this becomes a major issue. So along with ISDA, all of us are trying to share this knowledge that it's better to go in for same lot of material to be used for a particular application.
Okay. Further question, we'll be ready to answer these questions in writing to the respective email IDs. I think there are no further questions. So I'll request once again Mr. Pahuja to say a few words regarding the seminar, and then we'll conclude.
Thank you, Rohit, and thank you all the delegates and esteemed speakers for sparing their time to be with us and listen to us on this very important subject. Just to give things in proper perspective, globally the percentage of stainless steel consumption in architecture, building, and construction is about 15 to 16%, while in India we are just at about 8% or so. So we have a long way to go as far as the use of stainless steel is concerned in the building and construction. And now that the awareness is rising and people, and especially the government bodies, are also looking for sustainable solutions in building long-term infrastructure, more of aesthetics, and more recently on the emphasis on health issues and hygiene issues, I think the prospects of stainless steel usage are only bound to grow. And at the same time, as an industry, we have to prepare ourselves to meet this growing requirement, both in terms of quantity, quality, finishes, and fabrication practices. which we are doing as a association in our humble way, and we will continue those efforts. And if there are any more questions or doubts at any time, we have an email available where the queries can be sent, and we'll be very happy to answer it. And not only that, with the help of experts like Mr. Rao or our partner Nickel Institute or our industry experts, we are always available to answer all questions and give solutions to all issues. Thank you.
Thank you, sir. With this, I would officially like to close this webinar now. So thank you very much, everyone, for joining.
Thank you.
Thank you all.
Thank you, sir.